let's try a few product rule examples. First, if you have a polynomial, say x squared minus 5x multiplied with the exponential function, what's the derivative? The product rule, I should write down the product rule. It says if you differentiate f times g, that's f prime, you differentiate the first, leave the second, and this time you change roles. The prime gets stuck in the second one, okay? Now a lot of books have it the other way around. They write fg prime plus f prime of g. Each has their own advantages. I like this first one better because then it's easy to remember the quotient rule. Quotient rule is just this one with a minus sign rather than plus with g squared in the denominator. If you have f over g, it's this one with a minus sign in between, and you divide by g squared. But this one is good for differential equations later on if you ever need to learn differential equations. But since for applied math students, most people will be just doing at most math 112, which is just calculus 2. I think it's better to just use this one. Okay, so even though you may have learned your product rule in this format, try to do it this way. Okay. All right. So according to that formula that we just did, we have x squared minus 5x prime e to the x plus x squared minus 5x times e to the x prime. Now when you differentiate this, x squared differentiates to 2x, and then x differentiates to 1. See how I'm ignoring the negative 5? That negative 5 is a constant multiple of x, so you just leave it there, okay? Plus, what's the derivative of e to the x? It's just e to the x, right? So that's it. That's the derivative. Now, if you want to simplify this further, since they both have e to the x, we can factor the e to the x out, and you end up with 2x minus 5 plus x squared minus 5x. And since these 2x and negative 5x are like terms, you end up with x squared minus 3x minus 5 e to the x. Okay, let's do the next example. Now in this next example, I want to show you the same problem done in two different ways to assure you that indeed product rule gives you the same answer. Okay, the product rule gives you the correct answer. So think about the following: square root of x times let's do cube root of x. I think that's better. 3x minus 5. Let's try to differentiate this. Now, if you use the product rule, it says you differentiate only one of them, leave the other, then plus you differentiate the other one that you did not differentiate. Well, to differentiate this, you have to use the power rule. To use the power rule, cube root is same thing as 1/3 power. So you rewrite this as a power. That's the only way you can use this power rule. That's the one that I'm using, right? Prime 3x minus 5 plus, let's rewrite this anyways. You don't have to, but I'll just rewrite cube root of x as x to the 1/3. And then 3x prime, well, 3 is a constant multiple, so you just have to differentiate x, which is 1. So it's 3 times 1. And 5 is not a constant multiple, it's just the constant term. So in this case, this applies. So 5 prime gives you 0. Or 5 gives you 0. Derivative of 5 gives you 0. So what we get is applying the power rule, 1/3 comes down, subtract 1, that's negative 2/3, times 3x minus 5, plus x to the 1/3 times 3. Now, you can further simplify this by thinking of x as x to the first power. And when you expand this, you multiply this by distribution, then x to the negative 2/3 and x to the first power, they have the same base, so these two numbers add up. What's negative 2/3 plus 1? Negative 2/3 plus 1 is negative 2/3 plus 3/3, which is 1/3, right? So this just becomes x to the 1/3, and 3 times 1/3, that gives you 1, right? Minus 5 times x to the 2/3, negative 2/3, and then 3 times x to the 1/3. So these now become like terms. 1 plus 3 is 4, so 4 times x to the 1/3 minus 5 times x to the negative 2/3. Okay? So that's how you would do it using the product rule. However, for this type of questions, sometimes it's just better to simplify algebraically and then go from there. So let me show you the second method, method 2. First, rewrite the above as x to the 1/3 power, and think of x as x to the first power, and think of, and then you multiply by distribution before you differentiate. So we still have to differentiate. 1/3 plus 1 is what? That's 4/3, right? 1/3 plus 1 is 1/3 plus 3/3, which is 4/3, right? So that's 4/3, and then 3 is in the front. And then when you multiply this to any number, that's just this. But wait, we still haven't differentiated this yet, so we have to differentiate. And 3 and negative 5 are just constant multiples, so you're really differentiating x to the 4/3 and x to the 1/3. So this is 3 times 4/3 times x to the 1/3, because 4/3 minus 1 is 1/3, minus 5 times 1/3 comes down, and then you have x to the negative 2/3. Oh, you know what? By doing this, I just realized there was a mistake, because these two weren't going to be the same. See, when I multiply this to the second one, I should have had this 3 in the denominator, right? Okay. Alright, so now you can see that these two are the same thing, right? 3 cancels, and you end up with 4 times x to the 1/3. 5 times 1/3, that's 5/3, x to the negative 2/3. So you got the answer in a much quicker way by not using the product rule. You know, product rule is not a rule for convenience. It's a rule in the sense that it's like traffic rules. If you drive at 70 miles per hour where the speed limit is 50, then you get stopped and you get punished, right? You're going to be paying fines, right? So product rule, when you think about rules, a lot of times in English, rule has two things. One meaning is you follow some rule, you do it more conveniently, you do it really fast. That's one meaning of the rule. There's another rule where if you don't obey it, then you pay a fine, right? You get punished. And it's the second meaning of the rule that this product rule means. When you have a product of two things, and if you want to differentiate as it is, you must follow the product rule, which is differentiate the first, leave the second, leave the first, and differentiate the second. The only way to avoid using the product rule is to somehow make it as not a product. So when I distributed it, this is no longer a product, so I was able to just differentiate as it is, right? But that's very rare. In many cases, you're stuck with the formula, and it is a product, it is what it is, and you have to use the product rule, or else you're going to get the wrong answer. Okay, last simple one. Here's x squared times ln of x. Okay, what's the derivative? Product rule says differentiate, and then differentiate the other one. X squared differentiates to 2x, and ln x differentiates to 1 over x. So that's 2x ln of x, and then x squared divided by x is just x, right? So that is